All right, let's now come to a different type of question which is based on statistics, because you see the median, you see the mean and range. All right, so we are in the realm of statistics now. Mean, median, mode, range, standard dispersion, on all those things, right? So I hope you have done your homework on the topic. But just for your ready understanding, median is what? Median means it is the middle figure. It does not depend on the value, but it depends on the position of the data in the entire data set, right? Whereas mean depends on each of the values. It is the simple arithmetic. Mean or average would be you add all the numbers, given numbers, and divide by the number of data points. That's it, right? And range is what? The maximum value minus the final value minus the initial value of that data set. That gives you the range of the data, right? If the data is arranged in order. So we don't need to discuss SD, that is standard dispersion, etc. right now. If you need inputs on that, please comment. I'll be happy to make a video on statistics for you. Okay, all right, fine. So let's see this. If the median of a set consisting of n consecutive odd positive integers is an even integer, all right, the sum of the mean and the range of the set is an odd integer. All right, you can handle it in two ways. Okay, if you are an algebra geek, then you can work on maybe the ENOs, that is even odd concept, etc., or else you can take numbers. Okay, so let's see if possible we'll do it in both ways. Okay, so let's look at the solution. Now look, we are considering median. Okay, if the median of a set consisting of n consecutive odd positive integers. Okay, so first of all, if it is odd, that means if in terms of the variables, if I have to put an odd number, how do I do that? See, anything multiplied by 2, any number multiplied by 2 will always be even. Okay, if you want to make it odd, then you add 1 to it, that will be odd, or you reduce 1 from it, that will again be odd. You take an example, let's say I'm talking of an even number, let's say 4. You add 1 to it, it becomes odd, 5. You reduce 1 from 4, you get 3, that is also odd. Clear? So either I can put it as 2n plus 1 or I can put it as 2n minus 1. And it consists of n consecutive odd positive integers. So first of all, I have to take, let's say I would like to work with 2n plus 1. Okay, so I'll take this, but I have to consider whether there would be 3 terms in it, or that means odd number of terms, or there will be 4 terms in it, that means even number of terms, to consider both the possibilities. Okay, so let's plot it. For example, so let's take 2n plus 1, okay, 2n plus 3 and 2n plus 5. Why 2n plus 1? You know that. But why 2n plus 3? Because the next odd number would be 2 more than the previous odd number, right? So from 5, if I want to get to the next odd number, that means 7, then I have to add 2 to it, isn't it? That's why 2n plus 1 plus 2, that means 2n plus 3. And same way, 2n plus 3 plus 2, that means 2n plus 5. That will be, these are the 3 odd consecutive positive integers, and the median would be the middle one, that is 2n plus 3, which will be odd, right? Obviously these are all odd integers. Okay, but what is given? If the median of a set consisting of n consecutive odd positive integers is an even integer, okay, so this is possible only when I take 4 terms, that means even number of terms. Let's look at this. 2n plus 1, 2n plus 3, 2n plus 5 and 2n plus 7 would be the 4 consecutive odd positive integers, and the median of that will be the average of the middle 2 terms, right? That means 2n plus 3 plus 2n plus 5 divided by 2. That means 2n and 2n would be 4n, 5 plus 3 is 8, 4n plus 8 divided by 2. You can take 2 common from the numerator, so you will be left with 2n plus 4, and then this 2 and this 2 will cut. So 2n plus 4 is an even number. Look, even plus even is even. Okay, 2n is even and 4 is even. Even plus even is even. So this is now acceptable. That means we will have to work with 4 terms and we'll have to discard these 3 terms. Okay, so that means n consecutive. In this case, I know for sure that n is even. So let's proceed. Now, what will be the mean? We have to find the sum of the mean and the range. All right, the sum. Okay, we have to. So let's individually find the mean and the range. Mean is how much? Mean is the it is an AP, right? It is an arithmetic progression. Okay, all consecutive numbers, they make an AP, right? AP is what? Difference between the 2 numbers is a constant. So 2n plus 3 minus 2n plus 1 would be 2. Same way you take the next figure minus the previous figure, you will get 2, right? So mean for any for an AP, the mean is the first term plus the last term divided by 2. Incidentally, that will also be equal to the median, which we will see later. Okay, but right now let's not get into it. So the mean is T1 plus Tn divided by 2. That means 2n plus 1 plus 2n plus 7 divided by 2. That means 2n plus 2n is 4n, 7 plus 1 is 8, 8. So 4n plus 8 divided by 2, as we have seen before, that will be even, because 2 will come out and then you will be left with 2n plus 4, which will be even. We have seen that already. We have seen it here. Okay. And the range will be what? Range will be the final figure minus the initial first term, I mean. So 2n plus 7 is the last term minus the first term is 2n plus 1. Please put it in bracket, otherwise you may go wrong with the signs. So 2n plus 7 minus, in bracket 2n plus 1 will give you 2n plus 7 minus of 2n, and then when you open the bracket you get minus 1. All right. So what 2n and 2n cancel out, 7 minus 1 is 6, 6 is even, so even. So now you got the mean, you got the range of the set. Okay, and they say that the sum of the mean and the range of the set is an odd integer. That is what the problem says. So mean plus range is E plus E, that is even plus even. Even plus even is always even. So it says that it is an odd integer. This is not possible, and hence the answer is never. We are going to go with option choice C. Clear? Now look, it is not essential to take all these complicated 2n plus 1. I mean, I showed this to you so that in case if you are not able to work with numbers for some reason, then you can use these concepts, whatever concept is applicable to you in the future. Okay. For solving this, we could have done the same thing using numbers in a very simple manner. Let's see the alternative method. If you take 1, 3, 5, the median is 3, that is odd, so you will discard this. Let's take the set of odd numbers as consecutive odd numbers as 1, 3, 5, 7. That means I've taken 4 terms. Here the median would be the average of the middle two. That means you get 3 plus 5 by 2. That is 8 by 2. That is 4, which is even. So this is an acceptable data set. We will work with 1, 3, 5, 7. What is the range of this? The range would be last term minus first term. That means 7 minus 1 is 6, which is even. All right, we got the range. What is the mean? The mean is, we already found out the mean, right? So it will see, in fact, for consecutive numbers, you know that median is equal to mean. That is exactly what I did at in the initial solution. So median is equal to mean for consecutive sets or for arithmetic progression, right? So there it is. We had already found out mean was 4. So sum of the two would be even plus even, which will be even. So answer choice C, that is never, is correct. So it was as simple as that. All right, let's get to the next question, that is question number 18. Given A and B are positive integers and A is greater than B, okay, the median of a set consisting of 5 terms A square, AB, B square, A minus B square and A plus B square is AB. Whether it is true always or sometimes or never, that's the question. Let's look at the solution. Given is that A and B are positive integers and A is greater than B. That's what we need to keep in mind. And there are 5 terms. So we will have to see how these terms will see the median. Okay. To find the median, we will have to basically what we need to do, we need to put these terms in order. A square, AB, B square, A minus B square and A plus B square. And these 5 terms, 1, 2, 3, 4, 5, these terms we will have to put in order to see whether AB will be the middle term. Okay, that's how it will. So let's look at A and B are, they are positive integers. A is greater than B. Now look, A square will always be greater than AB. Why? Because A square is made up of A into A, and A is greater than B, and they are all positive integers. So definitely A times B will be smaller than A square, right? So for the same reason, A square will be greater than B square also, because A into A will be greater than B into B. And for the same reason, A times B will be greater than B into B, that is B square, isn't it? I hope you follow this. So this is very easy. Because A is greater than B, these relationships are pretty easy to comprehend, right? So what we get is A square is greater than AB, but AB is greater than B square. So we'll put A square greater than AB and AB is greater than B square. That's how it is. So we get this relationship. Now we are left with A minus B square and A plus B square. All right. So let's first see A minus B square with respect to A square. Now A square will be greater than A minus B square. Why? Because look, A is greater than B. So A times A will be obviously greater than something that you will reduce from A, isn't it? A is bigger than B and you are reducing something from A, that means you are reducing that value, and they are both positive, mind you, right? So we are dealing with only the positive integers. So A minus B will be smaller than A, isn't it? Or A will be greater than A minus B. So therefore A times A will be greater than A minus B times A minus B, and therefore this relationship A square greater than A minus B square, right? So now let us see A plus B square. How will that be? That now you are adding a positive number to another positive number. That means you are adding B to A. Obviously that will be greater, that will make it greater than A itself, isn't it? So A plus B square will be greater than A square. Now combining all these inequalities, what we get is A plus B whole square. Okay, from here A plus B square is greater than A square, this A square. Okay, so I know from here A plus B square is greater than A square, so I put A plus B square as the first term that is greater than A square. Then I already know A square is greater than AB is greater than B square, but I know that A square is greater than A minus B square, but I do not know where to fit in this A minus B square in this. A square is greater, so A minus B square could be anywhere after A square, right? But whether it will be in the position of AB or whether it will come at the place of B square, or whether it will be the last term in the among the five terms, whether it will be the last term. So I don't know that. But what I know is that A plus B square will be greater than A minus B square. Why? Because two positive numbers, you add them, the square of that is always greater than the square of the difference of the two numbers. You can take an example. Let's say A is 2, B is 1. A plus B square would be 2 plus 1, 3 square, 3 square would be 9. A minus B what? A minus B will be 1. So A minus B square is 1. So 9 is greater than 1. You can see that, right? Alright, let me delete that. Now look, A minus B square, let us take a couple of values to see how it compares with the other numbers. Okay, with the other terms I mean. Okay. Let's say we take A as 5 and B as 2. So A minus B square would be how much? 5 minus 2, that means 3 square. 3 square is 9. A square would be how much? 5 square is 25. B square is 2 square, that is 4. AB is how much? 5 into 2, that is 10. A plus B square is how much? 5 plus 2, that is 7. 7 square is 49. Now look, 49 is greater than 25, is greater than 10, is greater than 9, is greater than 4. Compare all these five values, 9, 25, 4, 10 and 49. So put them in order. That's how it is. So here we clearly see that this AB is fitting in between the five terms. That means AB is the median in this case, isn't it? A plus B square is greater than A square, is greater than AB, is greater than A minus B square, is greater than B square. So AB is right now fitting as a median. This is the median. Let's take another data set, another data point. Let's take A as 2, B as 1. A minus B square is 2 minus 1 is 1. So 1 square is 1. A square is 2 square, that is 4. B square is 1 square, that is 1. AB will be 2 times 1, that is 2. A plus B square will be 2 plus 1 square, that is 3 square, that is 9. And in this case, again, you can see that, stack them in order. So 1, 1, and then 2. And so this 2 will be the middle term. Then after 1 and 1, that will be 2. After 2, that will be 4 and 9 will be the other two terms on the right hand side of 2. That means 2, again, this will be the median. So can we safely conclude that AB would be the median? With this, it seems likely, right? But it is not. Why? Because we have not taken diverse data points. Okay, these are too close. 5 and 2 and 5 and 2 and 1, these are too close. The moment you take diverse data points, for example, you take A as 10 and B as 1, see what happens. A square will be 10 square would be 100, B square will be 1 square, that is 1, AB will be 10 times 1, that is 10, A plus B square will be 10 plus 1, 11 square, that is 121, A minus B square will be 10 minus 1, that is 9 square, that is 81. Now see what happens. A plus B square, now put them in order. Look, A plus B square is 121 is the greatest, followed by 100, that is A square, followed by A minus B square, that is 81. 81 is followed by A times B, that is 10, and AB, that is 10, is greater than B square, that is 1, right? In this case, A minus B square is the middle term, and that becomes your. So AB could sometimes be the median, but not always. So the answer is B, option choice B, that is sometimes. And the message is, or the tip is, take diverse sample, include all possibilities. So when you take your sample, my tip is always see here they had clearly told us that we needed only positive integers. But if suppose somebody mentions that it's an integer, suppose x is a or let's say a number n is an integer, then integer could be negative integer. Okay, 0 is also integer. It could be a positive integer also. Now if they instead of integer, if they say it's a real number, then the real number includes your integers as well as it includes your fractions. It could be 1 by 2, 1 by 4, whatever, right? Also, when you work on a number line, always understand that either the number could be on the right side of the number line, I mean those fractions, or it could be on the left hand side of the number line. Okay, take a very large number or take, I mean, or take a very small number. If you need to deal with two numbers, then maybe, as we have seen before, take numbers which are widely dispersed and take a set which is very, very close to each other. So look at all the possibilities, but always remember, division by zero is never permissible. This is not correct. This is not allowed. Okay, this is not admissible. Remember that always. So whenever you deal with anything, don't, if you are dividing by something, then if at any place, if there is a division by zero involved, then that will not be the appropriate thing to do. Look into it and discount that. Okay, so fair enough. Let's move on. Let's do question number 19. For a set of n integers in arithmetic progression, the difference between twice the median of the set and the range of the set is equal to twice the first term. Is it always, sometimes, or never? All right, how do we solve this? Let's look at the solution. So we are dealing with arithmetic progression. Let's take a plus d, a plus 2d, where d is the common difference. Let's take three terms. For a set of n integers, okay, they have not mentioned the number of terms, so we can probably we can take three terms. The difference between twice the median of the set and the range of the set is equal to twice the first term. So okay, the difference between twice the median would be a plus d, that is the middle number. So 2 times a plus d minus the range of the set. Range would be how much? A plus 2d minus a, the last term minus the first term. That means a and a will cut, so you will be left with 2d. Okay, so 2a plus 2d minus 2d will be, you will be left with only 2a. So is it equal to twice the first term? Yes, it is. That's true. So you have the solution. Now, even if you take 4 terms, let us check whether, okay, either it could be the, when you take n integers, it could be either the odd number of terms or it could be the even number of terms. Let's try and see this as well. As you can see on your screen, if you take a plus d, a plus 2d and a plus 3d, then the median would be the average of these two numbers. That means a plus d and a plus 2d divided by 2. What you are left with is 2a plus 3d divided by 2. And the range would be last term minus the first term, a plus 3d minus a, that means 3d. So it says that the difference between twice the median. So 2 times the median would be how much? 2 times of 2a plus 3d by 2 would be 2a plus 3d, right? Minus, so this 2 and this 2 will cancel. Minus the range of the set. Range of the set is how much? We just found that as 3d. Okay, minus 3d will be equal to how much? It should be equal to twice the first term. Let's see. So 2a plus 3d minus 3d. So this 3d, when this bracket will open up, this 3d minus 3d will cancel out. You will be left with only this 2a. So 2a, even if it is even, I mean it is true even for even number of terms. So essentially we can conclude that it will always be true. So option choice A. That's our answer. All right. Now alternative method is that instead of working with doing whatever we did, let's see AP. Okay, instead of working with 3 terms, 4 terms, let us just take an AP as it is. Okay, so A, let's say this will be, let's populate an AP. AP will be what? A plus D, A plus 2D and so on up to A plus n minus 1D, right? The last term would be A plus n minus 1D, clear? So what will be the mean? Mean will be equal to median will be equal to first term plus last term divided by 2. That's what I've been hinting at for an AP or for consecutive numbers, okay, which is essentially an AP. The mean will be equal to the median will be equal to the average of the first and the last term. So T1 plus Tn by 2. That means A plus last term would be A plus n minus 1d divided by 2. That means 2a plus n minus 1d by 2. Note where the parentheses are. Okay, note that carefully. So 2 times the median will be equal to, median would be 2a plus n minus 1d divided by 2. So this 2 and the other 2, this 2 will cancel out. This 2 will cancel out with this 2. What you will be left with is only this much. That is 2a plus n minus 1d. Range would be the last term minus the first term. Last term is a plus n minus 1d minus the first term is a. So you have this a will cancel out with this a. What you are left with is n minus 1d. Now 2 times the median minus the range would be how much? 2 times the median is 2a plus n minus 1d minus the range is n minus 1d. So n minus 1d and n minus d, they cancel out each other. What you are left with is 2a. So basically 2 times the first term. A is the first term. So that is always true. We solved it algebraically. Clear? This is an alternative method. Now we come to the last question of the quantitative reasoning section. Question number 20. Two sets of numbers having medians p and q respectively are combined to form a new set. If p is greater than q, then the median m of the new set satisfies q less than m less than p. That means this problem says that if you are taking two sets of numbers which respectively have medians p and q, and if you combine that set of numbers, okay, then essentially the median of the new set will lie between the other two medians. Now look, median does not depend on the data. Median is not affected by the value of the data. It is affected by the position of the data in the data set. That's what I right. So it is very unlikely that that median is going to follow a certain group, because it does not depend on the value of the data, but it depends only on the position of the data. But let's solve it arithmetically. So we know that median is the middle figure when numbers are arranged in order, right? So let's take this data set 5, 6 and 7. The median is 6. The middle number, let's say that is p, and p is higher than q, so we have to take another data set which has a median smaller than the median here. So I'll take 1, 2 and 3. So here the median is 2, so q is 2, p is greater than q. I maintain that. Now let me combine these two data sets. So 1, 2, 3 and 5, 6, 7. What will be the median of this? The median would be the average of 3 and 5, the middle two terms. So 3 plus 5, 8 by 2, that is 4. Now look, this is equal to m. So in this case, is m between p and q? Yes, it is. 4 is between 2 and 6. So q, that is 2, is less than m, that is 4, is less than p, that is 6. That is true. But remember, if you understand how to consider or how to find median, you will know this, that look, if the median is, let's say the data set is 1, 1, 1, 1, 1. Okay, it could be, I could have taken any number of ones. The median will always be the middle figure. In this case, it will be 1, and p I have to take higher, so let's take 5, 6, 7. If p is 6, p is greater than q. In this case, if we combine this data set, see what happens. 1, 1, 1, 1, 1, and then 5, 6, 7. So here 3 terms, here 3 terms. The median will be the average of the middle two terms. That means 1 plus 1 by 2. That means 2 by 2. That means 1. That is, m would be 1. And in this case, m is equal to q. So q less than m is less than p is false in this case. M is not falling in between q and p. So the answer choice clearly is sometimes. Sometimes m could be between p and q, but not always. All right. Here, it is important for you to note that we have not considered a set as a typical set in maths. That means you have your roster forms, union rules, intersection rules, and all those things. When you combine two data sets, in sets you don't repeat that. When you make the union, you don't repeat the data, right? It comes only once in the set. So if you need more inputs on sets, by the way, you may need that for your IPMAT, if not for your NPAT or for your SAT. 100% you will need it for your IPMAT, that is advanced math. So if you need that, please do comment, and I'll be happy to make a video for you for sets as well. So that brings us to the close of this session. I hope you enjoyed the video. If yes, please do give us a like and subscribe to my channel. Please hit that bell icon so that whenever I post content on math, English or soft skills, you are notified. Thank you so much for your time. I hope to see you very soon in my next video. Thank you. Happy learning.